These are kind of my steps that I would complete in order to solve these more complex equations, okay? These first two steps, you want to do these first two guys on both sides of the equal sign, okay? Sometimes you have to do these and sometimes you don't. It just depends on what the problem looks like. This third step happens if you have variables on both sides of the equal sign, okay? The problems today do not have variables on both sides of the equal sign, so we're really not going to do step 3 today. Step 3 is going to be for next week's problems, okay? And last but not least is step 4, which is you isolate the variable. This is what we've been working on the last 2 weeks, okay? Getting the variable by itself. So 1 and 2, these are not always going to happen, but you got to check for them for both sides of the equal sign. Step 3 is when you have variables on both sides of the equal sign, and step 4 is you always do. Okay, we're going to isolate. So let's get it going. Let's do number 1. Okay, so I'm still going to put my line in so I can know the left side and the right side. So we're going to check the left side first, and we're going to check on the left side, do I have anything to distribute? And the answer is no. The way you know when you have distributed property is you're going to have parentheses. If you look at the left side, no parentheses. So then we go to CLT, combine like terms. Well, on the left side, there's only one term. It's 0. So there's nothing to combine on the left side. So we check the left side. Now we're going to do the same thing for the right side. Do I have any parentheses on the right side to show distributed property? And the answer is no. There's no parentheses on the right side. Then I go to step 2. Do I have combined like terms on the right side? And this is where we say yes, we actually have x and x. So again, to remind you, like terms are when they have the same variable. We can combine them as long as they're on the same side of the equal sign. Okay? So like terms are same variables. Another version of like terms, if you look here down here at number 4, 2 and negative 3 would be like terms because they do not have variables. All right? So same variables are like terms, and numbers without variables are also like terms. All right? So number 1, we got to combine like terms. So what we're going to do is take this guy, positive 2x, and positive 2x. So again, that's positive 2x and positive 2x. When we combine them, we basically are adding or subtracting, and it's all dependent on signs. Since they're both positive, they're going to join together and stay positive. So that's going to give me positive 2 and positive 2 is positive 4, and then we bring the x along for the right. Okay, positive 4x equal to 0. All right, so we're done with step 1 and 2 for both sides. We go to step 3. This only happens when we have variables on both sides of the equal sign, which we do not. So we do not have to do step 3. And then step 4, we want to isolate the variable and solve. Okay? So we have to get x by itself, which means this 4 has to go away. And we know that this 4 is multiplying. So the opposite of multiplication is division. And what you do to one side, do to the other. 0 divided by 4 is 0, and then these 4's cancel out, and we're left with x. So 0 equals x. Okay, that was number 1. We're going to jump over to number 2 and do the same process. All right, left side, is there anything to distribute? No. Anything to combine like terms? No, it's only negative 1. Right side, anything to distribute? Nope, no parentheses. Combine like terms, and the answer is yes. We have positive 1 and negative 3. Those have to combine because they are like terms. They have no variables, so that makes them alike. So positive 1 and negative 3, when I put these two together, this is how I do it in my head is who's going to win? Who's bigger, the negative or the positive number? Well, I know the negative is bigger, so I know the negative is going to win. And if the positives and the negatives fought, who would win and by how much? So the negatives would win by 2. Okay? So that's how I kind of do the positive, negative math there. So now I'm going to bring down the p, and I'm going to put the p in front. Equals -1. We do not have variables on both sides, so step 3 we do not have to do. Step 4 says I want to isolate the variable. So to isolate the variable, I'm going to get rid of anything with my variable. So I need to get rid of the 2. What's the 2 doing? It's subtracting, which means I have to add. Again, negative and positive, we got to see who's going to win and by how much. So I know the positive is going to win, and it's going to win by 1. So it's +1 equals P. Okay. All right, we're going to jump over to 3. Again, same process over and over again. Do I have anything to distribute? No parentheses on the left side? Nope. How about CLT, combine like terms on the left side? And the answer is yes. I have positive M and positive M. This is really positive 1M and positive 1M. So positive 1 and positive 1, that gives me positive 2. And I bring the M down, equals. Now let's check the right side. Anything to distribute on the right side? Nope. Any combined like terms? Nope. So it's -2. We do not have variables on both sides, so step 3 we do not have to do. Step 4, I want to isolate the M, which means I have to get rid of the 2, and we know that the 2 is multiplying. And the opposite of multiplication is division. So what you do to one side, do to the other. M is going to equal -1. Okay, so this is what we're going to do, number 4. Okay, I'm going to give you about 2 minutes to do number 4, and I'm going to call on 2 people to give me the answer. Okay, so go ahead, 2 minutes. All right, cool. So those are that one style problem. Now we're going to go ahead and shift over to the next set. Okay. What you'll notice is these problems here do have parentheses. So I want to make sure we are comfortable in doing these. All right. Same steps apply, but these are a little bit more complex. All right. So let's try number 5 together. So number 5, we're going to put that line in just like before. Okay. And then we're going to look for, we'll start on the left side. Do I have distributive property? And the answer is yes. I have parentheses, and I have a number on the outside. And we have to remember this number on the outside really just means multiplication. Okay. So I put a little multiplication sign. When it's written right next to it, that's multiplication. And since it's parentheses, we want to distribute the 3 and multiply with the 4. So 3 times 4 is 12. And then we go 3 times the next guy, which is positive. 3 times 3 is positive 9, and then x. And we bring down the 48 on the right side. Okay, still working on the left side. Do we have any combining like terms? And the answer is no. But now we look at the right side. No parentheses, so we don't have to distribute, and no combining like terms. The right side is good to go. Okay, so now we want to go ahead and check for number 3. Do I have variables on each side? Nope. So step 3 we do not have to do. Step 4, I want to isolate the variable, in this case the x, which means I have to get rid of the multiplication of 9, and I have to get rid of 12. And we know 12, if you look at the sign in front, 12 is adding. Okay, so we want to get rid of addition first, as long as it's not being divided, which it's not. So to get rid of an addition, we want to do subtraction to both sides. The 12s cancel out. We're left with 9 times x on the left side equals to 36 on the right. Positive 36. And now to get rid of multiplication of 9, we're going to divide 9 to both sides. Okay, and we get x equal to 4. Okay, let's do number 6. All right, same steps apply. Let's start with the left side. We do have distributed property because 4 is multiplying. So I'm going to go here and here and multiply. So 4 times 2r, this gives me 8r. 4 times negative 4, that gives me negative 16. Okay, you'll bring down the negative 48. So we distributed. Do I have any like terms here? Nope. So now we go to the other side. Do I have any distribution? Nope. Do I have any like terms? No. Step 3. Are there variables on both sides? No. So now we just go to step 4. We want to isolate. We know that 8 is multiplying, and we know the 16 is subtracting. So we always want to get rid of addition, subtraction first. So I'm going to get rid of 16 by adding 16 to both sides. 16's cancel, we're left with 8 times r equals 32, actually negative 32. And to get rid of multiplication of r, we do division of 8 to both sides. These 8's cancel, r equals negative 4. Okay? All right, guys, so 7 and 8, I'm going to call on 2 people each. 2 people to do 7 and 2 people to do 8. I'm going to give you about, let's do 6-7 minutes, and then be ready to share if you're called upon. So we're going to add 12 to both sides. Oops. Okay, negative 16, positive 12. Be careful with your signs here. This is going to give me negative 48. And then we get 16 times n. And then to get rid of the 16, we're going to divide 16 to both sides. And this is going to equal to negative 3 equals n. Okay, so just a common mistake here is signs. Some people get 72 out of this, negative 60 and positive 12. They'll add them together and get 72. Just careful with your signs here. And then the other common mistake is when we divide here, people forget the negative. So it's 48, negative 48 divided by 16 is negative 3. Okay, let's jump over to 8. 8's a little suspicious, and here's the reason why. When we do the left side, we have to distribute, but we're not distributing a negative. What we're really distributing is this negative is really a negative 1. Okay, so just think of it that way. Even though it says negative, it's really negative 1. So we're really going to multiply negative 1 times negative 2. That's positive 2b. Negative 1 times negative 3. That's positive 3. Equal to 11. There's no CLT here. There's no distribute or CLT here. So now we're going to get rid of 3 and 2. So the one we want to get rid of first is 3 because it's adding. The opposite of addition is subtraction. So we're left with 2b, or 2 times b equals 8. And then we're going to divide both sides by 2. So that's going to give us b equal to 4. Okay. All right, guys. You're going to add these problems to today's assignment. So you're going to have a total of 16 problems to turn in. All All right, so the assignment that's due today, the upload, I think it's 1 through 8. Add these to it. All right. Okay, guys, that's all I have for you. I'm going to give you the access code now. And then you'll be dismissed to go make sure, one, you check in. That's one thing I forgot to mention. Check-ins are now worth points. So if you don't check in, you're going to be missing some participation points. So check in, finish your assignment today. Make sure you did watch the notes from yesterday and turn those in from yesterday if you haven't done that. And then I will see you guys on Friday, okay? So stay on if you need extra help. If not, you are dismissed, and your access code today is BED. BED.